Hello, Pre-Calc Honors. Back again. I am doing page 10 today, power rule. So, after a few days of doing the definition of derivative, which is rather lengthy, takes a lot of steps, you got to do a lot of algebra, you have to do the limit at the end, and then you get the derivative, we now learn the shortcut, which is called the power rule. So, at the top here, I have 4 problems that came up in the packet so far. The first day, and then this came up again the second day. This equation right here, or this function I should say, h of t equals 800t minus 16t squared. The derivative was 800 minus 32t. So there's a way to get from here to here without having to go through the whole definition of derivative. Skipping down to number 3, one of the functions we did at some point was f of x equals 2x plus 1, and the derivative was just 2. So at this point, you should be thinking, do I notice any patterns? In number 2, g of x equals 4x squared minus 3x, and the derivative is 8x minus 3. So if we were in class, this is where we would break off and I would have you discuss in your groups and think about theories. Like people would start noticing things like, this is a degree of 2, and this is a degree of 1, this is a degree of 5, this is a degree of 4. The degree keeps going down 1. Okay, so what keeps happening? And some of the numbers are the same, some of the numbers kind of look like they're related somehow. Well, if I take this example in the next box and find the derivative, maybe you should pause the video just for a second because I'm going to give you the derivative to this guy right now. If you think you have a theory, pause it. Okay, write down what you think the answer is and then come back and see if it matches my answer. The derivative for this guy is 14 x to the 6th minus 12x cubed plus 2. Okay, so how did I get that so quickly without going through the whole definition of derivative? Well, the power rule says you take the exponent, you multiply it to the coefficient, and that replaces the coefficient. So you notice I did 7 times 2 and put the 14 here. Then you subtract 1 from the exponent, and it happens in that order. Okay, if I think about the next term, I take 4, multiply it to 3. It stays negative, and I get 12. The 12 goes here. Then I subtract 1 from the 4, and I've got 3. In the next one, the exponent's not written. I'm just going to write the term 2x up here. It would be 2x to the first. So 1 times 2 is going to give me 2. And then x minus 1 would be x to the 0, but we never write x to the 0. X to the 0 is just 1. That's why that just turns into a 2. And then if I have to write an exponent, when I think about the constants, this is a weird thing to think about, but this would be like -5. If I had to put an x here, it would be x to the 0. So this still works if I'm applying the power rule. 0 times 5 gives me 0, and 0 times anything, no matter what that ends up being, is 0. Okay, we don't really think of it like that. We just think of it like the derivative of a constant is always 0, and we're going to write that down below. So that's the power rule. And yes, I made you go through the long whole definition of derivative because that's just how it works. You still need to recognize the definition of derivative, and after working with it and doing the algebra with it for so long, it should stick out when you see a definition of derivative filled in, like day 4 lesson. All right, so to summarize the power rule, I'm using a term here. I just let the coefficient be a and the exponent be n so that we can generalize what the derivative looks like with the power rule. I would take n multiply it to a, and that's going to be my new coefficient. And then my exponent, my new exponent, is going to be n minus 1. Okay? Constant rule, that's what I was saying, the constant rule. If f of x is a constant, then the derivative is 0. Okay? I'm going to go on a side note for a second again. Think about a constant. I'm trying to erase, but it's not working. Okay, forget it. I'm not going to erase. Just move this, just give myself some room. Okay, a constant, the graph of a constant. Okay, just let's say it's 2. Looks like that. Well, what is the slope at any point along that line? The slope right here is 0. 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 So it doesn't matter where I am on that line, the slope is always going to be 0. That's why the derivative of a constant is always going to be 0. Okay. All right, let's practice this power rule. Number 5. Use the notation too. So f prime of x equals 2 times 5 gives me a 10 there, and it's going to be a 10x to the first, plus anytime I just have an x, it's really just the number in front, the coefficient. Number 6, f prime of x equals 6 times 5 is going to give me a 30 out in front, x to the 5th, plus 3. Number 7, this is a diagonal line. The derivative here is just going to be 2. Now let's go into that one a little bit graphically. This is a diagonal line with a positive slope. Just like I was showing you above with the constant, no matter where I am on this line, the slope is going to be 2. That's why the derivative is just the constant, the slope 2. 8, derivative is 7. The derivative of this plain old 8 is 0, and the derivative of 7x is 7. 9, this is a constant, so the derivative is 0. Okay, try 10. Pause the video for a second, try 10, and then come back and see if it's the same. Okay, so 4 times 3, 12x squared, 2 times 2, 4x minus 3. There's your derivative. So easy. So how can the power rule, not be so easy or even be messed up? Because anytime you're given something like 5 through 10 there, finding the derivative should be super quick. Everybody should get it right every time. So this is why we were doing that practice. If you see below, you'll see negative exponents and x's on the bottom. This is why we were practicing that leading up to it. Because sometimes you have to find the derivative and it's not just a nice polynomial like it was in 5 through 10. Here, we just have to deal with negatives. Okay, so I always want to use the power rule. When I'm using the power rule, I always want to be looking at the function as, coefficient x and then to an exponent. I'm never applying the power rule with x's on the bottom, like 13, 14. I'm never applying the power rule when I see a radical in there. Everything always needs to be rewritten first, if that's the case. And we're going to have to rewrite first in 13 and 14. In 11, we're good to go. The power rule is used when I'm looking at a power. So, I'm ready to start writing the derivative. Negative 1 times 5 is negative 5x. And keep in mind, negative 1 minus 1 puts us at negative 2, not 0. We're subtracting 1. Now, I'm always going to want your final answers written in without negative exponents. So after we find the derivative, this right here took us, it's important to use the notation, this is regular f of x, now I have the derivative, and then I'm going to rewrite my answer. Negative 5 over x squared. Okay. 12. We're ready to start with the derivative because I'm looking at x to an exponent. So the derivative is negative 6 x to the negative 3 minus, because that negative 1 comes down, 2 x to the negative 2. And then we rewrite. Negative 6 over x cubed minus 2 over x squared. And this is just something I would say in class. Like, there aren't explicit directions saying that, but I would have you prepared for always expressing your answer with positive exponents, which means bringing those negatives back down. Okay, 2 more. Okay, I'm going to just try my best to write neatly here. Okay, so this is going to have 3 steps to it. And I'm going to be careful about my label. What I'm doing right here is rewriting. I'm rewriting this to prep so that I can use the power rule. This is x to the negative 5 plus x to the negative 1. I'm bringing those x's up to the top. I'm not doing the power rule when x's are on the bottom. That whole rule we talked about, bring the exponent down, multiply it, subtract 1, that rule applies as long as your x's are on the top. Okay, so notice my notation didn't change there. My notation was still f of x. Those two things are equivalent. Now I'm going to take a derivative. So my notation changes to f prime of x. Using the power rule, this becomes negative 5 x to the negative 6 when I subtract 1, negative 1 x to the negative 2. Just be careful with those exponents and, changing your sign. The next step is just a rewrite again. This is going to be equivalent. My first line was equivalent to the original problem. When I went to the red pen, I changed it. Now I'm talking about the derivative. And my final answer is the derivative. It's just written with positive exponents. Negative 5 over x to the 6th minus 1 over x squared. Why don't you try the last problem real quick, pause it, and then come back and see if we agree. You could probably finish the problem by the time it takes me to move over. Okay, so we are rewriting. First step is rewriting. X to the negative 3 plus x to the negative 2 minus x to the negative 1 plus 1. Make sure that line is equivalent, okay? Make sure that line is completely equivalent. I'll probably talk more about that on the next day. Okay, now we're taking a derivative. Negative 3x to the negative 4 minus 2x to the negative 3 plus, because the negative times the negative, x to the negative 2, and the derivative of 1 is 0, so that 1 goes away. Rewriting so that we have everything written with positive exponents. Again, notation, f prime of x. That's usually, students a lot of times won't write this because they just don't, that's not part of my answer. Write it. Show in your work that this guy is just the original. Show that, okay, now this is the derivative, and this is the derivative. Negative 3 over x to the 4th minus 2 over x cubed plus 1 over x squared. Okay, there's the power rule. All right, hope everybody's doing well. Bye.